Hey everybody, Mr. Enyart here, eating some phenomenal Twizzlers. It's actually licorice from Bass Pro Shop, best licorice ever. Anyway, we're going to be doing lesson 19 today from Module 4 in Eureka Math 6th grade. We're going to be substituting and evaluating addition and subtraction expressions where we have a variable and then we're given information. Let's say someone tells us a number, or we have a table that tells us the number. We have data that tells us the number, and we plug it in to the expression and then solve. It's super awesome. We're going to have a good time. Stick around. Let's do some math.
Mr. Enyart is here to help. Let's go.
So basically, with this lesson, we want to try and think through a word problem or through a table given to us. What information can we figure out? So when I was not born, my sister was 2. That tells me a lot, right? Tells me that she is 2 years older than me. So obviously, when I was 1, she became 3. So every year I grow older, she grows older. Funny how that works. But what expression could I write that I could that would define this information mathematically? Okay, so let's say I want to look for my years. How old am I? Okay, I'll tell you how old I am, but I'm only going to tell you my sister's age. Okay, so we're going to say that we don't know my age, right? I shouldn't be writing in white. We don't know my age, but we know that it has some relationship with my sister's age and something. What is happening? If I had my sister's age, what would I do to it to find my age? Yeah, I would have to subtract 2 from my sister's age, and I would get my age. Now let's do it the other way. What if I want to find my sister's age, and I'm going to give you my age? What would I have to do with my age, right, and something, to find my sister's age? Excellent. I'd have to add 2. Now this is going to help us answer questions about the information. So look at letter B on our practice. It says, on the day I turned 8 years old, how old was my sister? Now remember, my sister is how many years older? That's right, she's 2 years older. So if I turned 8, right, if my age was 8, and I plug that into my equation of how old is my sister? Of S equals M plus 2, right? If I plug that in, I take this 8 and I plug it in for M, then I have S equals 8 plus 2, which of course S would therefore equal 10. And that's simply plugging it in. So we literally took this 8 and since it's our M, my age, and we're going to throw it into the M in our equation that we wrote, and then life becomes a lot easier, right? So when I turned 16, how old was my sister? Again, now we've got M equals 8, and, not 8, forgive me, equals 16, and we have the equation, my sister's age equals my age plus 2, and so we plug in the 16 for M, and we say that S equals 16 plus 2, so her age would be 18. Cool, right? All right, so let's skip down to example 2. We've got another thing of my age and my sister's age, 0 and 2, 1 and 3, 2 and 4. So what can we say? Again, we can say a couple things. We could say that my age is my sister's age minus 2, and we can say that my sister's age is my age plus 2, right? So I can tell you that M stands for my age, right? That's my age. And the S stands for my sister's age. And of course that is in years, because we learned in lesson 18 to be specific with our units. So how old was I when my sister was 6 years old? Which equation would I use? Right, so I know S, I don't know M. So I want to use this one, M equals S minus 2. And then I'm going to plug in, right, S equals 6. So it's going to be M equals 6 minus 2, right? So therefore, I was 4. I was 4 years old, right? And down here, how old was I when my sister was 15? Well, obviously, I'm using the same equation, right? I'm still using my age, I don't know, but I know that my sister's minus 2 equals my age. And if S equals 15, then my age equals 15 minus 2, and therefore my age was 13. Pretty simple stuff, right? Loving it. Okay, so let's just go through this exercise all together. And I think if you're understanding this one, you're pausing and going back and watching the right parts of the movie to help you understand, then all the rest of the table's questions throughout the entire lesson will make perfect sense. So let's start by reading carefully. Noah and Carter are collecting box tops for their school. They each bring 1 box top per day starting on the first day of school. So we're given some information here, right? They're doing 1 per day, so they're growing by the same rate. All right. However, Carter had a head start because his aunt sent him 15 box tops before school began. So it looks like he had a 15 box top head start, right? I bet you that's going to be important information. Noah's grandma saved 10 box tops, and Noah added those to his first day. Okay, so all right. So Carter was given 15, but Noah was given 10. So there's even more information. So they're both not starting at 1, right? Neither person is starting. They said 1 per day, but he's starting at 15. He's starting at 10. And then they're bringing 1 per day. So you can see that these numbers reflect that. 11 represents the 10 that he started with. Noah started with 10, right? And then on day 1, he brought 1 more. So 10 plus 1 is 11. The box tops Carter has is 16 because he started with 15, and then on day 1, he brought 1 more, and 15 plus 1 is 16. So now that we've described the table and read carefully, day 2, that would mean he'd bring another box top, right? So we'd be filling in 1 more on top of 11, which would be, that's right, 12, and 1 more on top of 16, which would be, that's right, 17. So you can see our gap between the two in this direction are the same, right? So to get from 11 to 16, that's 5. So he's at plus 5 more, and he's at minus 5 of Carter's, right? So at this point, I'm going to write some equations, right? I'm going to think, what are my relationships here? How do the days connect to Noah and Carter? How does Noah connect to Carter in the days? And then how does Carter connect to Noah in the days? Because everything's growing at the same rate. And so I'm going to start with my connection to Noah and Carter, right? So if I don't know Noah's, right, I can take Carter's and do what with it? Yeah, I can subtract 5, right? And if I don't know Carter's, right, I can take Noah's and do what with it? That's right, add 5. But what about this school day? What if I want to figure out, I've got their numbers, but I don't know what the school day, right? What can I see there in connection between the school day and then Noah and Carter's information? And this is where it gets really cool, because in all reality, I only need 1 kid's to figure out what the school day is. So let's say I'm using Noah's, and I want to find the school day, right? What's the difference between Noah's and the school day? Do you see 11 goes to 1, 12 to 2? This will be 13 to 3, 14 to 4, and 15 to 5. Well, it looks like if I just subtract 10, or the amount that he started with, right, I get the school day. So if I had Noah's amount, and I subtract 10, I'm going to get the school day. And then on the other side, what if I only had Carter's amount? Right, I'm going to do that over here. So I have Carter's amount. Well, how does that connect? How does 16 connect to 1, 17 to 2, 18 to 3, 19 to 4, and 20 to 5? Right, you're taking away 15. Okay, taking away 15 because that's the amount he started with. Okay, so now I've pretty much found all my relationships. Let's now say that I had the school day, but I don't have Noah's and I don't have Carter's. Could I take the school day, so let's say Noah's here, right? Noah's equals the school day and what? That's right, plus 10. If I add 10 to the school day, I get Noah's. And then with Carter's, I take the school day and I add 15. So look at all these relationships, all these different things I can draw. And again, it might be helpful to say that, C is Carter's box tops, right? Carter's total box tops, because we want to be specific. And that would be brought to school, perhaps. And then N stands for Noah's. And then for sake of time, I'm just going to do this little thing here, right? And then D stands for days, right? So D stands for school days. Now let's go through and answer some questions. If we let D, the number of school days since new school, and on D days of school, how many box tops will Noah have brought? Well, again, that's us saying we know the days, but we don't know Noah. So that would be this equation. Noah equals the school days plus 10, right? And that'll tell us how many Noah has. So on day D of school, how many box tops will Carter have? So again, we're looking for Carter. We don't know Carter's, but we know how many school days there are, and we're going to add 15 to that. We will figure out Carter's information. On day 10, all right, now we're plugging in. Right, now we're plugging in D equals 10. How many box tops will Noah have brought? So again, that's going to be this equation. So Noah equals D plus 10. All right, now we know that D equals 10. So Noah equals 10 plus 10, right? So therefore, Noah would have brought 20 box tops. And then if we do the same thing here with Carter, here we're using this equation, right? Carter equals D plus 15, and at this point, D equals 10 still. So we're going to write that Carter equals 10 plus 15, right? And therefore, Carter would have 25 box tops brought. And that still fits, right, our rule. It's a difference of 5. It fits every one of those equations. So
I know this one took a little bit longer. Sorry. I did try to limit the work I was doing, but wanted to be very clear in my explanation as to how to find relationships from numbers using variables and relationships from tables using variables as well. And then, most importantly, how to plug in that information to find unknown information. So if you have any more questions or concerns, feel free to comment below. If not, keep rocking that math.